before we get to the latest things, we want to think, because we're doing gases now, okay? We want to think chemistry plus physics. Okay, so if I have a container full of gas, or Wanda, give me some properties of this gas according to chemistry.
Teacher, they're far apart.
Okay, they're far apart.
They are not in a fixed position.
Okay, not in a fixed position, so random motion. Anything else? Chloe, can you think of anything else?
Teacher, they collide off one another a little bit quicker than the other properties, the other states, I mean.
They collide. Okay, do they just collide against each other?
No.
Teacher, and the walls of the container.
And the wall.
Yeah.
Okay. Again, what can we tell about their speed? Maria.
The speed will increase if it's heated up.
Okay, just sorry, there's an airplane crowing over my head now. Okay, you can say again.
The speed will increase if it's heated up.
Okay, if we compare gases, you are correct there. If we compare gases to other liquids or solids, what do we know about the speed?
They're quicker.
Okay, they move fast. And we're going to get to Maria's conclusion just now. Okay, guys, in terms of physics, there are two things that is very, very important. The collisions and the speed. Now, how does that link up to physics and especially pressure? Who can give me a guess? Maya?
Teacher, when a container is closed, I mean, the smaller the container, the more often the particles hit the wall of the container.
Okay, and how does that link up to pressure?
Teacher, I'm not sure.
Wanda?
Because pressure is force over area.
Okay, well done.
So if the area is smaller, the pressure is higher.
Okay, and if the force is bigger, the pressure is higher. Now, where does this force come from?
From the collisions.
Okay, so if we look here, here is my container, here is my molecule, it goes towards and it goes away, right? It bumps and goes back. So it has it's got a mass and an initial velocity and a mass and a final velocity. And what does this lead to? A change in momentum over a period of time, which is a resultant force. So as they bump into the sides of the containers, there's a change in direction. That change in direction gives rise to a change in momentum. Change in momentum gives us a resultant force, and that resultant force is given over an area which causes pressure. So simply stated, when the molecules collide against each other and against the walls, they cause pressure. Okay, so this gives us pressure. I've just shown you the physics behind it. What is the speed of the particles? Maria, what can you say about the speed of the particles? Just tell us what you said initially.
Well, they get fast.
Okay, and you said when they heat them up, they
They increase in speed.
increase in speed. Okay, so Well done, Maria. If we look under a microscope, okay, or let's say a electron microscope or something that we could actually see the movement of particles. If I look at hot water and cold water, or let's make it a substance that you could actually physically see the molecules. Would they change color? How would we identify that these molecules were hot and these were cold? If it's a substance that we could see under a microscope, would their atomic composition be different? Anyone?
I think the
No.
motion of the particles would just be faster.
Okay, the motion would be faster, but do you guys agree we can't change the composition of the atoms?
Yeah.
Okay, so the only difference between a hot molecule and a cold molecule is the speed. Okay, and although we haven't done it yet, speed equals energy. What type of energy is the energy of speed? Who can remember from previous years? Anshu?
Kinetic.
Kinetic. Okay, so we've got kinetic energy. So the speed is related to kinetic energy, and the collisions is related to pressure. Okay, so when I heat it up, there's going to be more energy, but also more collisions more often. Okay, when I make the size of the container smaller, okay, they're not going to move faster if the temperature stays constant, but they are going to bounce or bump into each other more. So let's just apply this to Boyle's law. Who can remember from the presentation what's Boyle's law? Formula for
Work equals
not that one.
work. Oh, okay.
The pressure volume one.
Oh, teacher,
Maya.
it is when we have a high pressure, we'll have a low volume and vice versa.
Okay, so
Pressure is version, sorry.
Here we have a syringe with a big volume, okay, and a low pressure. When I push in the syringe, this was on Monday's upload, by the way, Monday's video. When we push in the syringe, we have a low volume and a big pressure. Okay, so the formula for Boyle's law was that the volume times the pressure in one scenario is always equal to the volume times the pressure in a second scenario. Okay, and what was the condition for this? That the temperature remains constant. Okay, so the reason that this happens is, okay, collisions and pressure can either come from, okay, collisions, or, well, it can either come from a smaller space, or so if I increase pressure, it can either come because the space is smaller or there's more kinetic energy. Okay, because the faster I move in the same space, I'm going to collide more. Or if I move at the same speed but in a smaller space, I'm going to collide more. Both of them increases the pressure. So in terms of Boyle's law and gases, if I have particles in here, they are colliding against the side of the container because there is, okay, they have a certain amount of energy and they are moving. When I decrease the size of the container, I have the same amount of molecules in a smaller space, so they're going to collide more often. But since the temperature doesn't change, it's not because they've got more kinetic energy, it's just because there's less space for them to move. Okay, and that is Boyle's law in terms of chemistry. Okay, very important what I just explained to you guys now, and it might have helped you with some of those questions.